All right, let's get right into it. We're going to tackle a huge debate in system architecture today. When do you stick with good old comfortable rest, and when do you really need to jump to something built for pure, raw speed? This isn't just about chasing trends, it's about making the right call when performance is everything. This quote, it just nails it. The whole conversation isn't about which one is better in some abstract way. It's about what happens when you push a system to its limits, when every single millisecond matters and things start to break. Look, we all get rest. It's the language of the web, and for good reason. It's easy to understand and use. But when you put it under the incredible stress of modern systems, we're talking tons of microservices, real-time data, massive numbers of users all at once, well, that's when its core design starts to show its age.
And here's where the friction really comes from. First, you've got JSON. It's great for us humans to read, but for a machine to constantly process that text, it's heavy. Then, on top of that, you have all these wordy headers on every single request. And the real killer, it's all built on HTTP/1.1. Think of it like a single-lane road. Only one car can go through at a time. So when you have thousands of cars trying to get through, you get a total traffic jam. That's your data bottleneck right there.
So if that's where rest hits a wall, what's the answer? Well, this is where gRPC enters the picture. It wasn't really designed to just replace rest entirely. No, it was created as a very specific fix for these exact performance problems we're talking about. It fundamentally rethinks how machines should talk to each other. And here's the fundamental difference, right? It's a total shift in thinking. Instead of human-readable text, gRPC uses a super compact binary format. And instead of that old single-lane road of HTTP/1.1, it's built on a modern, multi-lane superhighway, HTTP/2. This isn't a small tweak, it's a completely different engine. Okay, so how does this new foundation actually translate into real-world speed? What's the secret sauce here? Let's break down the core pieces that make gRPC so incredibly fast and efficient for these kinds of jobs. The heart of gRPC is HTTP/2. This is the superhighway all the data travels on. And it's not just a minor update from HTTP/1.1. It's a total overhaul that opens up a whole new world of possibilities that just weren't possible before. So with multiplexing, you can send a bunch of requests and get responses all at the same time over one single connection. No more waiting in line. The data itself is sent in a binary format, which means it's way smaller and faster for machines to process. And the connection stays open, which cuts out all the time wasted setting up new connections over and over. For a user, this is the difference between something feeling laggy and something feeling instant. Now for the other half of the magic, protocol buffers, or protobufs. So instead of sending what looks like a text document, gRPC uses protobufs to package data into these tiny, machine-perfect binary messages. The process of turning data into this format is just lightning fast. A machine doesn't have to read and figure out a sentence anymore. It's just getting a perfectly formed block of data it instantly understands.
But here's the other brilliant part. It's not just about speed. Protobufs add a huge layer of safety. Imagine you're building with Legos. With protobufs, every service gets a precise instruction manual. You know exactly what piece is, what it does, and where it goes. There's zero guesswork. This stops those sneaky, silent breaking changes that can take an entire system down. It just makes sure machines are speaking the same language correctly every single time.
And this is an absolute game changer. With gRPC, you can have a real, continuous, two-way conversation between services, all happening over that one connection. Think about what that means for things like live chat, or real-time stock tickers, or updates from IoT devices. You just can't do that efficiently with the old ask-and-wait model of rest. And it's not just about raw performance. gRPC is designed for how we actually build software today. Because of those strict instruction manuals, those contracts we talked about, it can automatically write a ton of the client and server code for you in almost any language you want. This makes building and maintaining a complex system of microservices so much simpler. Which brings us to the final and honestly the most important point. This isn't about throwing rest in the trash. It's not about replacing it everywhere. It's about understanding the trade-offs and making a smart, deliberate choice for what your system actually needs. And I think this statement frames it perfectly. gRPC isn't just the new, cool, shiny thing. It's a necessary evolution. It's a correction for a specific class of problems that have just gotten too big and too fast for the way traditional APIs were designed. This really boils it all down, doesn't it? Rest is the familiar road. It's comfortable, and everybody knows how to drive on it. But when performance isn't just a nice-to-have, when it's a core requirement, gRPC is the competent choice. It's the specialized, high-performance vehicle you bring out for the race. So ultimately, when you're designing your next service, the choice is yours. Are you going to stick with the comfort of the standard that works for most things? Or do you need to reach for the competence that's required for those really demanding performance challenges? The right answer? Well, it depends entirely on what you're trying to build.